Day 18 of 90, and today we fixed the lie hiding in almost every TypeScript codebase. You write a function that returns a user. The signature says user. But it can also throw a network failure, an auth error, a bad response, and your typed system says nothing about it. The caller has no idea anything can go wrong. By the end of these 5 minutes, your compiler will refuse to let you forget a single failure path. Let's make errors first class. Here's the production scenario. A front-end fetch breaks silently. You wrote try, catch, E. In modern TypeScript, E is typed as unknown, and that's correct, because anything can be thrown. But then someone does, E as any, message to make the red squiggle go away. That cast is where safety dies. Unknown in a catch block is right, but incomplete. It tells you, I don't know what this is. It doesn't tell you what your code can actually fail with. So let's name our failures. Instead of throwing strings, model errors as data using a discriminated union. Watch, type API error equals, kind, network, status, number, kind, auth, message, string, kind, validation, fields, string, kind, rate limit, retry after, number. That kind field is the discriminate. Every variant carries exactly the data you need to recover from it. Now an error isn't a mystery object, it's a value with a shape the compiler understands. Next, stop throwing entirely at your boundaries. Build a result type, no library needed. Type result T, E equals, OK, true, value, T, OK, false, error, E. That's the whole thing. A function returns result user, API error instead of promise user that secretly explodes. Now success and failure are both right there in the return type. The caller literally cannot access .value without first checking if result.ok. The compiler narrows it for you. Failure stops being a surprise and becomes part of the contract. Let's wrap an actual API client. Async function getUser, ID, string promise result user, API error. Inside, you fetch. If the response is 401, you return, OK, false, error, kind, auth, message, token expired. If it's 429, kind, rate limit with retry after. On success, return, OK, true, value, user. No throws cross this boundary. Every caller of getUser now sees, from the signature alone, the 4 exact ways it can fail and gets the data to handle each one. Now the magic exhaustive narrowing in a React component. You call getUser, check if result.ok, and switch result.error.kind. Case network renders a retry button. Case auth redirects to login. Case validation shows the bad fields. Case rate limit shows a countdown. Then add a default case with const_exhaustive, never equals result.error. Here's the payoff. The day a teammate adds a server error variant to the union, that never assignment breaks the build. The compiler points straight at every component that forgot to handle it. Unhandled errors become compile errors. One more tool for digging into errors safely. When you do need to inspect an unknown thrown value, don't cast to any, narrow it. Write a typeguard, function is API error, E, unknown E is API error. And use satisfies to validate your error objects against the union without widening their type, const error equals, kind, auth, message, no, satisfies API error. You get autocomplete, you get checking, and you keep the literal type or satisfies validates the shape, it never erases what you know. When should you use which? Use result types at boundaries, SDK methods, API clients, anything a caller must consciously handle. That's where explicit beats implicit. Keep throwing exceptions for true and variant violations, bugs that should crash, like this should never happen. Expected failures are data. Unexpected failures are exceptions. The newer Stripe-style SDKs lean explicit for exactly this reason. Your contract should tell the truth. Day 18 done. The takeaway, model errors as typed data with discriminated unions and result types. And the compiler enforces every recovery path for you. Subscribe for day 19.
you.